Students, before this we have studied 4 lessons, and that gravitation is there. After that, periodic classification of element is there, chemical reactions and equations, and 4th lesson we have studied effects of electric current. Now 5th lesson is there, and that 5th lesson is there heat. So this heat topic is related to the physics. So before this also related to heat, you have studied many concepts, and in that two concepts are there, main two concepts are there, and in a textbook, can you recall, in that also some questions are asked, and in that first question is there, what is the difference between heat and temperature? So heat means what and temperature means what? So this concept, before this you have studied heat and temperature. So in case of heat, suppose you are heating any substance, then whatever heat is given to that particular substance, if you are heating it, then what happens, that heat is absorbed by that particles of that medium, and that particles of medium, they become, or they are getting kinetic energy. So and temperature of that substance or that particular object increases. So what is meant by heat and what is meant by temperature, that difference we are going to study. So in the form of difference only we will see that one. So in case of heat and temperature, so first thing is there, here heat is there, and suppose you will take to that side, you will take temperature. So heat and temperature. So in case of the heat, first we will take points and then I will write. So in case of the heat is the form of energy. Heat is the form of energy, and it measures total energy of all molecules in that substance. So what is the heat? It is the form of energy and which measures total energy of all the molecules or all the particles in that substance. Again, in case of heat, it is total kinetic energy of all molecules or particles of the substance, total kinetic energy. So if you are providing heat to any substance, then particles of medium, they get set into the kinetic energy, and total kinetic energy of all the molecules or all the particles of that substance, it is called as a heat. The next thing is there, what is the unit of heat? So SI unit of heat is there joule, and CGS unit of heat is there calorie. So SI unit joule and CGS unit is there calorie. Another fourth point, in case of the heat, so in case of the transmission of heat, total amount of heat remains unchanged. In case of transmission of heat, total amount of heat remains unchanged. You can give an example. Sun is giving that heat energy is transmitted or transferred from the sun, but energy of sun is not going on decreasing. So during the transmission, total amount of heat remains unchanged. Next thing is there, in case of the temperature. So temperature is the degree of hotness or coldness of the body. It is degree of hotness or coldness of the body, And the second point, you can tell, in case of the temperature, it is the measure of average kinetic energy of molecules or particles of medium. It is the measure of average kinetic energy of all the particles of medium. So it is called as a temperature, average kinetic energy, and the total kinetic energy is heat. So next thing is there, what are the units of temperature? So temperature is measured in three units. Degree Celsius is there, Kelvin is there, and last one is there, Fahrenheit. Degree Celsius, Kelvin, and Fahrenheit. So another thing is there, in case of the transmission, in the transmission of heat, temperature changes. In the transmission of heat, temperature changes. Suppose that heat radiation or radiations or that heat energy is coming from the sun, temperature on the earth or temperature of the object present on the earth increases. So during the transmission of heat, temperature of that particular objects or that particular on which object that temperature heat is falling or heat is transferred, that object temperature increases. So in case of the heat and temperature, first thing is there, in case of heat, it is the form of energy and it measures total energy of, it is the form of energy and measures total energy of all particles or molecules of substance. Total energy of particles, or molecules, total energy of particles or molecules of a substance, Okay. So again, in case of temperature, what is there? It is the degree of measure of hotness or coldness of an object. It is the degree of measure of hotness or coldness of an object, So in case of second point, in case of the heat, it is total kinetic energy of all molecules or particles of substance. It is total kinetic energy of all molecules or particles of substance of our body, Second point, in case of the temperature, it is the average kinetic energy of all particles. It is average kinetic energy of all particles or molecules of a substance. The next point, in case of the heat, it is related to the units. In that SI unit is there. Joule, and CGS unit is there, calorie. And in case of the temperature is having 3 units. Which 3 units in that? First one is there, degree Celsius or a degree Celsius symbol is there. Second thing is there, Kelvin. Second is there, Kelvin, and into bracket K. Another unit is there, Fahrenheit. So next one is there, Fahrenheit. So Fahrenheit you are showing like this way. So temperature having 3 units. So fourth point is there. In case of the fourth point, in the transmission of heat or in the transmission, total amount of heat remains unchanged. In the transmission of heat, total amount of heat remains unchanged. In the transmission, total amount of heat remains unchanged. And fourth point here, in the transmission of heat, temperature changes in the transmission of heat, temperature changes. There is change in the temperature. So these are the points related to the heat and temperature. So after this, next question is there, what are the ways of transfer of heat? Next question is there, what are the ways of transfer of heat? So in that ways of transfer of heat, there are 3 ways of transfer of heat. So that 3 ways of transfer of heat you have studied in 7th standard and 8th standard also. So that 3 ways of transfer of heat, or also you can say modes of transfer of heat. Also you can say modes of transfer of heat. And in that first mode of transfer of heat, or first way of transfer of heat, is their conduction. First way is there. So ways or modes of transfer of heat. So what are the ways, what are the modes of transfer of heat? So in case of the ways or modes of transfer of heat, in that first way is their conduction. So what is mean by conduction? Conduction is there, convection is there, and radiation is there. There are 3 modes of transfer of heat, 3 ways of transfer of heat. In that first one is the conduction. So with the help of example we will take, suppose you will take one iron rod. And in one end of that iron rod you will hit, and here you are fixing wax pieces. So what happens, you are heating, this is hot end and this one is their cold end, hotter end and cold end. So what happens, if you are heating one end, heat is transferred from hot end to the cold end. So one end you are heating, but another end also gets heated, and that heat is transferred from hotter end to the colder end. So what happens here, suppose heat will reach here, this one will fall down, again this one will fall down, this one will fall down. Like this way you can identify there is a transfer of heat. So what happens, definition of that particular conduction. Conduction is the mode or way of transfer of heat in which heat is transferred from hot end to the cold end, hotter end to the colder end, without actual movement of the particles of the medium. The mode of transfer of heat without actual movement of the particles of medium, it is called as a conduction. So do you understand conduction? The mode of transfer of heat, definition you can tell. The mode of transfer of heat from hotter end to colder end without actual movement of particles of medium. Movement of particles of medium is called conduction. So what is the conduction? The mode of transfer of heat from hotter end to the colder end of substance or any material without actual movement of particles of medium. An example you can tell, it takes place in solids. You can take example in case of iron rod. Conduction occurs in the solids, only in the solids, and in that without actual movement of particles of medium. This statement is important, these words are important. Second mode of transfer of heat is their convection. Convection. So it is the way of transfer of heat or mode of transfer of heat in which heat is transferred from hot end to a cool end, or heat is transferred from one end to another end. Heat is transferred from one end to another end with actual movement of particles of medium. With actual movement of particles of medium, it is called as a convection. So definition you can write: the mode of transfer of heat, mode of transfer of heat from one point to another point, one point to another point, or one end, also you can say one end to another end, one end to another end with actual movement of particles of medium, particles of medium is called convection, is called as a convection. So it is the mode of transfer of heat from one end to another end, or from hotter end to the colder end with actual movement of particles of medium is called as a convection. And an example is there: it occurs in fluids, like liquids and gases. It occurs in liquids and gases. So another way of transfer of heat is there, and this one you can take example. Suppose in a vessel you will take water, and here you will take KMNO4 crystals you will take, and in this water you are taking. So if you will heat this one, after heating, what will take place? So crystals KMNO4, so it will get dissolved, and that particular color is moving in upward direction. So particles are getting colored and they are moving in upward direction. So it shows. So when water becomes hot, that water becomes hot and it becomes lightweight and it is moving upward direction, and then cold water comes in downward direction. That means here actual movement of particles of medium takes place. So third mode of transfer of heat is there, and that third mode of transfer of heat is radiation. Next mode of transfer of heat is the radiation, and in case of radiation, so radiation occurs without medium. So third one is there, radiation. So what is radiation? Definition we can take: the mode of transfer of heat without the medium. The mode of transfer of heat without medium, it is called as a radiation. Or what is the radiation? Mode of transfer of heat in the form of electromagnetic radiation. It is called as a radiation. So the mode of transfer of heat with or without medium, mode of transfer of heat with or without medium is called radiation. So in another example you can take: transfer of heat from sun to earth, and this transfer of heat takes place in the form of electromagnetic radiation. It takes place in the form of electromagnetic radiation. Electromagnetic waves also you can say, in the form of electromagnetic waves. So like this way, this is the example. And another thing also you can do. Suppose you will draw one vessel and you are heating that vessel with help of fire. You are heating, and here in this water is there, liquid is there, and this one is metal vessel is there. So this one heat is transferred from that particular, suppose flame is there, it will be given to this metal. This one will be conduction to metal, then conduction. It will, here it will get heated, but this one will become hot. Here you are heating, but this another end is becoming hot. So to the metal heat is there conduction. So in the liquid, convection takes place. In the liquid, convection takes place. And suppose heat is also passed. Suppose your hand is here, it is also passed through the air. So here, suppose your hand will be here, then this one will be radiation. This one will be radiation. Through the air it is passing, it will be radiation. Radiation will be conduction to the metal, convection to the liquid, and radiation. When you are sitting nearby that particular fire, then you are spreading your hands, then your hands are feeling hot, your hands are feeling heat. It is the radiation. So these are the ways, or these are the modes of transfer of heat. After this, next point is there. Two important concepts are there, and which are most essential for studying the latent heat of evaporation, for studying anomalous behavior of water. And in that, first concept is their expansion. Then the next one is their contraction. So what is meant by expansion and what is meant by contraction, these points we have to study. So next terms are there, and these also you can say effects of heat. Effects of heat, in that when you are heating any substance, then expansion takes place. So what do you mean by expansion? And when you are heating any substance, when you are cooling any substance, then contraction takes place. So there are two terms, expansion, and another term is the contraction. Expansion and contraction. So in case of expansion, if you are heating any substance, then size of that particular substance or size of that particular object increases, length of that object increases, area increases, or volume increases. So what happens after heating? When we heat any substance, change in length, change in area, and a change in volume takes place. Substance or object also you can see. Substance or object. Change in volume takes place is called expansion. Now here change means also you can say increase. Change means increase. Increase in volume, increase in length, increase in area, increase in volume. It is called as a expansion. So many examples you can give about expansion. So suppose in the x you want to fix in a stick. Suppose one x is there like this, and that one you want to fix, and one stick is there like this. So if you want to fix it, so what that particular iron smith is doing is hitting that particular X. So this ring, whatever this ring is there, size of ring increases, and so easily he is inserting that particular X. He is inserting X into, he is inserting X into that particular stick, and when it will be cool, then it will fit, or it gets fit. So like this way. And another thing is that suppose you will one ring experiment, ring and ball experiment is there. Suppose one ball is there, ring and ball experiment is there. Suppose one ring is there and one ball is there, and it will hit, and this one, so this one you are fixing to one handle, and this ball you will this ball you would tie to one chain. Suppose like this way chain is there, you are holding this one. If you will hit it without hitting, if you are without hitting, it will pass through this particular ring. But when you will hit, then size increases, volume increases, so it cannot pass through the ring. And when you will cool it, then again it can pass through the ring. It is called as a ring and ball experiment. So in this expansion, change in size, increasing volume, increasing length, and increasing area takes place. So expansion is of types are there, 3 types are there. First one is there linear expansion. In that, change in length, increase in length, increase in length. Second one is the aerial expansion. And in case of aerial expansion, area increases. And third one is the volumetric expansion. And in that, what will take place? Volume increases. So increase in length, increasing area, increasing volume. On heating, it is called as expansion. And opposite to expansion, on cooling, length, area, and volume of an object decreases. It is called contraction. It is called as a contraction. So increasing length, area, volume, expansion on heating, and decreasing length, area, volume on cooling, it is called as a contraction. So expansion, contraction, you understood. Next thing is the next term is the latent heat. Next term is the latent heat. So what is latent heat? So if you will understand that expansion and contraction, then next terms are easy to understand. So next thing is the latent heat, and in that latent heat, there are 2 types of latent heats are there: latent heat of fusion and latent heat of vaporization. So next term is the latent heat. So this concept is new for you, but it is easy. So latent heat, for that also one experiment is given. So what you have to do, suppose you will take one stand, you will take again one tripod stand, you will take like this way. Here will be one burner will be there. here will be one burner. After that, one vessel you will take, glass vessel you will take, beaker also you can take. So vessel you are taking, glass vessel. In that you are taking ice cubes or pieces of ice pieces you are taking, and with the help of clamp you have to fix one thermometer. Here, and thermometer bulb you will fix. Thermometer bulb will be there in the ice cube, and here in this thermometer mercury line will be there, mercury line. Okay, this one is their stand, this one is their beaker, burner. Here this one is their stand, tripod stand, ice cubes, ice pieces. Here it will be thermometer. Okay, so what happens now? You like this way your arrangement. You are taking one beaker, in that you are taking ice cube, in that you are inserting one thermometer bulb you are inserting, then ice cubes, beaker is there, stand is there, burner is there. And if you start heating, so ice at 0 degrees Celsius, ice is there. So what will happen? Initial temperature will be 0 degrees Celsius. So when you are starting to heat, heat, at that time ice will start to melt. But temperature of that particular mixture, that means ice and water, and it will remain constant. Initially temperature will remain constant, 0 degrees Celsius. It will remain constant till all ice will melt and it will get converted into water. So temperature will remain constant, 0 degrees Celsius, till all the ice will get converted into water. And the next thing is there, again if you are going to continue that one heating, again after 0 degrees Celsius, when all ice is getting converted into water, then temperature will start to increase, and that temperature will increase from 0 to 100 degrees Celsius. That temperature will increase up to 100 degrees Celsius. So again at 100 degrees Celsius, again water will get converted into its vapor. Vapors. So what will happen at 100 degrees Celsius? Again temperature will remain constant. At 100 degrees Celsius, again temperature will remain constant. Why it will remain constant? Because at 100 degrees Celsius there is also change in state. Liquid is getting converted into volume. Liquid is getting converted into its vapors. Then at that time also temperature remains constant till all water will get converted into its vapors. So this is condition, and one graph is given there, and with the help of graph also we'll see. So first thing is there, what you can say, when you are heating that particular ice, temperature will remain constant at 0 degrees Celsius till all ice will get converted into water. When all ice will get converted into water, then temperature will start to increase from 0 to 100 degrees Celsius. Then 100 degrees Celsius also temperature remains constant. At 100 degrees Celsius also temperature remains constant till all water will get converted into its vapors. Okay, so that one we'll see, and explanation of that particular graph also we'll see. So what happens? 2-3 points we'll take off this one, and then we'll study graph also. So first point of that activity or that particular experiment. First point, when ice is heated, it starts to melt. And temperature of mixture remains constant, that is 0 degrees Celsius, till all ice gets converted into water. When all ice converts into water, then temperature starts to increase from 0 degrees Celsius to 100 degrees Celsius. Continuously that temperature goes on increasing. Third point is that at 100 degrees Celsius, temperature remains constant. Till all water gets converted. All water converts into its vapors. These 3 points are important. At 100 degrees Celsius, temperature remains constant till all water converts into its vapors. So, one thing is clear. So, at 0 degrees Celsius, temperature remains constant till all ice get converted into water. That means here change in state is there. That means solid get converted into liquid. So during this conversion, temperature remains constant at 0 degrees Celsius, and at 0 degrees Celsius you are heating continuously, but temperature remains constant. But at 0 degrees Celsius, so this constant temperature, it is called as a melting point. Constant temperature at which solid converts into liquid, it is called as a melting point. You can say melting point here. So again, at 0 degrees Celsius, ice is absorbing heat, and that heat is utilized to break intermolecular force between, or interparticle force between particles of that particular ice or molecules of water, molecules of that particular solid. So that heat is absorbed to weaken the bonds or to break the bonds, and then that solid get converted into liquid. So that constant temperature at which heat is absorbed, or heat absorbed at constant temperature to convert solid into liquid. It is called as a latent heat of fusion. That concept we'll see, but before that we'll study graph of this one. And here also we can say at 100 degrees Celsius there is also change in state. So liquid get converted into vapors, or you can say gas. Liquid get converted into gaseous state. So here also temperature remains constant, and here also that particular heat energy is absorbed at constant temperature, and liquid is getting converted into gaseous state. It is called as a boiling point. Constant temperature at which liquid get converted into its vapors or liquid get converted into gaseous state, it is called as a boiling point. And here also is latent heat of vaporization. That terms we will study after this. So for this graphically we are going to study. So we will draw this graph. After this we are going to draw graph and explanation we will see. So in case of latent heat, for this experiment we are going to draw the graph, and after that the explanation we will see. So graph is on x-axis you are drawing time, you are taking time, and on y-axis you are taking temperature. So suppose like this way you are taking suppose like this. Here 0, 0 is there. On x-axis you are taking time, and it will be in minutes. Time will be in minutes. So here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Like this way, time in minutes. And here you are taking temperature. Here you are taking temperature. Like this way you will take temperature. Here suppose 10, 20, 30, 40, 50, 60, 70, 80, 90, and suppose you take 100 degrees Celsius. So temperature you are taking in degree Celsius, and time you are taking in minutes. So here suppose here A point is there initially. Here is A. Suppose here is B. Suppose here is B point. 4 is there, here B point is there, and here A point is there. So if you are heating ice, here at 0 degrees Celsius ice is there, but between 0 when you are heating and here AB, along AB two states are there, solid plus liquid, here AB. Again when you are heating, that temperature remains constant at 0 degrees Celsius. Here 0 degree is there, 0 degree. So when all ice will get melt, then the temperature will start to increase. Continuously, and here will be 100 degrees Celsius. Suppose A, B, here is C, and here will be D. So in this here water state is there, or you can say liquid is there, and here between C to D here vaporization starts. So here vapors, or you can say upper side vapors are there, or here again two states are existing. Which one? Liquid plus gaseous state. So here what you can say, water plus water vapors, So like this way graph is there. So what happen if you will see the explanation of graph. So first thing is there, if you will observe AB curve, or if you will see AB, so line AB, or graph AB. What it suggests, when you are heating that particular ice at 0 degrees Celsius, then ice will start to melt. Ice will start to melt, and at AB, two states are existing. One is solid phase, another one is there liquid phase. Ice and water, two states are there. Which one? Ice plus water mixture is there. Ice plus water. So temperature will remain constant. Suppose up to 4 minutes, temperature will remain constant 0 degrees Celsius till all ice melts and it get converted into water. When all ice at after 4 minutes, suppose ice gets converted, all ice get converted into water, then temperature will start to increase. Temperature will start to increase, and after increasing temperature, so 0 to 100 degrees Celsius temperature will go on increasing, and here liquid phase exists or water exists. And here at 100 degrees Celsius, again temperature remains constant 100 degree, because here also there is transformation of phase. There is conversion of liquid into gaseous state. Here two states are existing, liquid and gas, water and its vapors. So AB, which states are there? Temperature remains constant, that is 0 degrees Celsius, and there two states are existing, solid plus liquid or ice plus water. Next thing is there. So here constant temperature 0 degrees Celsius, at which solid melts, solid get converted into liquid, it is called as a melting point. Here you can give the definition: melting point. What is melting point? Constant temperature at which solid converts into liquid is called melting point. So melting point of ice is there, therefore melting point of ice is 0 degrees Celsius. At 0 degrees Celsius, ice get converted into water, so melting point of ice is there 0. Next thing is there, latent heat of fusion. So when you are heating ice up to 4 minutes, temperature is remaining constant. For some minutes, temperature is remaining constant 0 degrees Celsius. But why temperature remains constant? Heat is absorbed by ice. To convert it into liquid or water, and that heat absorbed at constant temperature. That is 0 degrees Celsius. Heat absorbed at constant temperature to convert solid into liquid. It is called as a latent heat of evaporation. And so this latent heat of fusion is there. So latent heat of fusion, at constant temperature, heat is absorbed by solid to convert solid into liquid. It is called as a latent heat of fusion. So what is definition? The heat energy absorbed at constant temperature. To convert or to transform solid, to transform solid into liquid, solid into liquid phase, is called latent heat of fusion. Fusion means melting. Latent heat of fusion. So heat energy, also you can say amount of heat energy, also you can say amount of the amount of heat energy absorbed, the amount of heat energy absorbed at constant temperature to transform, to convert solid into liquid phase, it is called as a latent heat of fusion. And for what purpose it is used? So latent heat of fusion is used to break intermolecular force of attraction, intermolecular force of attraction of solid, intermolecular force of attraction, so it will get converted into liquid. So do you understand melting point and latent heat of fusion? Amount of heat energy absorbed at constant temperature, that means at 0 degrees Celsius constant temperature heat is absorbed, but during this absorption of heat it is used to convert or to transform solid into liquid phase, it is called as the latent heat of fusion. So another thing, after this AB line is there. Now next thing we are going to next concept we'll see latent heat of fusion, but specific latent heat, another concept is there. Another concept is there, specific latent heat. So specific word is simple only, in that just you have to write unit mass of substance. Next term is there, specific latent heat, specific latent heat. So what is specific latent heat? Definition you can write. Definition: the amount of heat absorbed, amount of heat energy, also you can say amount of heat energy absorbed at constant temperature by unit mass of a solid, to convert into liquid phase, is called specific latent heat. Specific latent heat of fusion. Specific latent heat of fusion. The amount of heat energy absorbed at constant temperature by unit mass of solid to convert into liquid is called specific latent heat of fusion. So about AB we have studied. Next thing is there about next BC line. What BC line represent? Along line BC only liquid phase, that is water, exists. Okay, so temperature increases, and here temperature increases from 0 degrees Celsius to 100 degrees Celsius. Temperature increases from 0 degrees Celsius to 100 degrees Celsius. So next thing we are going to learn, and that one is about CD, line CD. So here along the line CD line, what takes place along the graph CD? So first thing is there, temperature remains constant. Temperature remains constant, that is 100 degrees Celsius. Second point is there, two phases exist. Which two phases are there? Liquid plus gaseous. Liquid plus gaseous, that is water plus vapors. Water plus its vapors. But here along CD temperature remains constant, that is it remains 100 degrees Celsius till temperature remains constant till all water gets converted into its vapors. But at constant temperature heat is absorbed. Temperature is remaining constant, so at that temperature liquid is getting converted into its vapor. Liquid is getting converted to gaseous state, so it is called as a melting point. So here boiling point. So here definition of boiling point. Constant temperature at which, you can say here, constant temperature at which liquid get converted into its vapors. Liquid get converted into gaseous state. It is called as a boiling point. The constant temperature at which liquid get transformed into its vapors is called boiling point. So at constant temperature liquid is getting converted into gaseous state. We can call that boiling point. Here next concept is the latent heat of vaporization. So listen, along CD temperature remains constant, it remains 100 degrees Celsius, but heating process is continuously going on. But at 100 degrees Celsius heat is absorbed by water. At 100 degrees Celsius water is absorbing heat to convert it into gaseous state. So latent heat of vaporization, and that heat absorbed at 100 degrees Celsius, it is utilized to break the intermolecular force between liquid molecules, and it will get converted into vapors or gaseous state. So it is used to weaken the bonds or to break the bonds. So latent heat, definition you can write. Latent heat, amount of heat energy absorbed at constant temperature to convert, or at constant temperature during conversion of liquid into its gaseous state, or you can say vapors. Amount of heat energy absorbed at constant temperature during conversion of liquid into its gaseous state or vapor. It is called as a latent heat. Is called latent heat of vaporization. So process is their vaporization. Amount of heat energy absorbed at constant temperature during conversion or to convert liquid into its gaseous state is called as latent heat of vaporization. And one more definition is the concept is that one is the latent heat of or specific latent heat of vaporization. So next definition is the specific latent heat of vaporization. 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 So in that same definition there, just you have to add at constant temperature by unit mass of liquid. One word only you have to add. So definition: amount of heat energy absorbed by unit amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert into its vapors. Is called latent heat of vaporization. So simple concept is the latent heat, amount of heat energy absorbed at constant temperature to convert solid into liquid, fusion, latent heat of fusion. To convert liquid into gas, it is latent heat of vaporization. And specific is also next concept. Okay, so remaining part we'll study in next video.